Now I'm going to show you the difference of squares. We will use the formula to solve them. And the formula is a squared minus b squared equals, and in its factored form it's a plus b, a minus b. Now for this problem I need to think, what am I squaring that's equivalent to the first term, and what am I squaring that's equivalent to the second term? So what do I square to get 4x squared? And the answer is 2x. And what do I square to get 25y squared? Well, I know I'm going to need a y, and the square root of 25 is just 5, so it's going to be 2x squared minus 2x quantity squared minus 5y quantity squared. So now I have my a, which is 2x, and my b, which is 5y. And they're each being squared, as you can see. So on my factored form, I put just the part in the parentheses with a plus in between, and the same thing but with a minus this time. So I put 2x and 5y for each set of parentheses. Those are the things that are being squared to make each of the terms. In one binomial it's going to be plus, and the other binomial is going to be minus. Now that's a really easy shortcut for difference of squares. And to check, anytime I'm using a new method, I would always like to check just to be sure that it really worked the way I thought it should. So I'll use FOIL, and 2x times 2x will give me 4x squared. 2x times negative 5y, negative 10xy. And then 5y times 2x will give me positive 10xy. And then 5y times negative 5y will be negative 25y squared. Now I'd like to combine like terms. I've got these two. They are exactly the same but opposite signs, so it's like you have 10xy and you take away 10xy, there's nothing left. So what I have is 4x squared minus 25y squared, and so that's what I started with, and my answer definitely checks. One more problem, and it's a difference between two terms, and I'd love it to be a difference of squares, but 50 is not a perfect square and neither is 32. But since they're both even, I'm thinking, wow, I wonder if I can just do a greatest common factor first. So let's try that. If I pull out a greatest common factor, I know that I can pull out at least a 2, and I'm left with 25x squared minus 16. And now I can see that the 25 is a perfect square and the 16 is a perfect square, and I no longer have any greatest common factors, so I'm ready to use my formula here for the difference of squares. And I really want to know, what am I squaring for the first term and what am I squaring for the second term? So for the first term, 5 times 5 is 25, so I know I'm squaring 5 to get the 25, and then x is showing as squared, so I just put a single x there. This quantity squared, remember 5x squared, is the same thing as 5x times 5x, which is 25x squared. So those are equivalent. And then 16, what do you square to get 16? Well, that's a 4. And now I can use the 5x for my a and the 4 for my b. So I'll have 5x and 4, 5x and 4. One set has a plus in between, the other set has a minus, and of course I can't forget that 2 out front. Now when I multiply these two to check, I get 5x times 5x, so that's 25x squared. I get 5x minus 4, so that's minus 20x. I get 4 times 5x, so that's plus 20x. And I get 4 times negative 4, so that's negative 16. And I have the 2 out front to multiply. These cancel, and I have 25x squared minus 16 times 2, and when I distribute that 2, I have 50x squared minus 32, and that is what I started with right there.